Okay, we're going to be looking in chapter 13 with the F distribution and one-way ANOVA, which is ANOVA stands for analysis of variance. So first of all, we're going to be using the F distribution, and it's skewed to the right, just like chi-squared was. The shape depends on your degrees of freedom, like chi-squared did, but this is kind of the standard what it looks like. And it's used to test. It's used as a test statistic for testing the equality of 3 or more population means. So your null is going to be mu sub 1 is equal mu sub 2 equal mu sub 3 equal ... mu sub x. So you have to have at least 3. And your alternative is going to be at least one of the means is different from the others. So it's not really too bad. I pulled up a picture here to show you what it looks like. Okay. And I'll probably bring up stat. We'll be using StatDist to complete it here. Let me see if I can get StatDist on the same thing. Looks like I have the problem we're given. A hospital wants to determine if the type of treatment for pneumonia is a factor in recovery time. The table below shows the number of days to recover for several randomly selected pneumonia patients that had various types of treatment. Okay, so we have the overnight hospital stay, a few hours in the hospital, and sent home with medicine. And then you're given the recovery time in days here. So notice that your null is the recovery time for overnight hospital stay, a few hours in the hospital, and sent home with medicine. That all 3 recovery times are the same. And then your alternative, and notice they do H sub 1, we normally do H sub 8, is at least 2 of the means different from each other. I think the way that I put it is at least one of the means is different from the other. So at least 1 means 1 or more, so at least 2 of the means, it's essentially the same thing. So you may see it differently in different books. Okay. So, how are we going to do this? So let's go ahead and see if this comes in nicely in StatDist. Okay, sample editor. I need to clear that out. I may need to go on over here just a little bit. There we go. Clear it. Okay. We'll slide this thing back over, and we're not going to be on contingency tables. I'm just going to go ahead and hit Control V. See how it posts in. Okay. 755, 18, 17, 4. Notice that they're different sample sizes here. Okay. Okay, looks like it came in good, which is great. So, we're going to be using ANOVA. I feel like it probably should have okay, ANOVA. I felt like it probably should have said F test here, but that's okay. Analysis. One-way analysis of variance. Okay. We'll do 1, 2, and 3. I'm using the data. What was the alpha level? 0.01. Evaluate. Okay. Let me see if I can get my back up here. And well, that's going to the bottom. That's okay. So F, or test statistic, and her p-value. Okay. You know the rule, if p is less than alpha, or less than or equal to, depending on which book you're looking at, you're going to reject the null in favor of the alternative. Okay, and conclude at least 2 of the means are different. So 3 decimal places here. It's going to be 6.298. That's going to be the 9's going to go to, so that's going to be 0.300. Okay. Might get by with simply 6.3, don't know. P-value 0.0076. Okay, alpha 0.10, yeah. P is less than alpha, therefore we're going to reject the null in favor of the alternative. Less than or equal to alpha. You never accept a null, by the way. We're going to reject the null. And there is sufficient evidence to support the claim that the treatment type is a factor in recovery time. So let's choose that one. Submit. And let me know if you have any questions. Thanks.